Good afternoon. Welcome to the next lecture on small assembly concert halls for Erasmus students at the Faculty of Architecture, Wrocław University of Science and Technology. Today it's a bonus lecture, so it's a lecture prepared for special requests of students who wanted to know something about the large concert halls. I am Joanna Jabłońska and I am assistant professor at the faculty. So today I will discuss with you three different types of concert halls. And the first the type is the hybrid concert hall, and this is the one that you can see here.
Spotkane są dodatkowo problemy. Mi się wydaje. Sufit z tym jasnymi podniesieniami super.
This is the main room in Dresno Palace der Kultur, so the Palace of Culture. Throughout the history, there were several different types of the concert halls. The first one that you can see here is the one that was designed in ancient Greece, and it was a natural hill, benches around the round stage, and that was basically everything. After some time, they started to build the wooden, then the stone theaters, and some of the stone theaters you can still see nowadays. The next building is the development of that Greek theater with the building behind the stage. These type of theaters have been undercover, so they haven't been covered. So in that way, there was no problem with the lines, with the acoustical reflections, bounces coming from everywhere. Also, it was very silent. At this time, there were no planes, no traffic, no additional machines humming, so you could hear everything very well. And also, this type of theater had a very good reflection from the stage when it was made of stone, of course. And this reflection was reinforcing the sound that was coming to the ears of the listeners. Then there was a Roman theater. What Romans did, they allowed a theater to have no longer the need for a natural hill. It was the structure, and on that structure they built their theaters. The Odeon Theater D was built both in Greece and in Rome, and it was a smaller, much smaller amphitheater, but also with raising auditorium. And this auditorium was also made of stone, of course, and the theater was covered with wooden coverage. Of course, the coverage didn't last to our times. Then the E-type, it's a Elizabethan theater, and this theater was the theater that had all the listeners very close to the sound source because the people were standing on the balconies. So it wasn't so comfortable, but at the same time, it was very, you could hear and see everything quite well because you were standing on the balconies. The balconies were quite flat. They weren't so deep, so they didn't create such a lot of reverberation. What is more, the theater was also uncovered, so you didn't have the problem with the reflections not going anywhere because they could always leave through the roof. Theater F is the opera shape of the theater. Very uncomfortable, uncomfortable for the sound, not good for sound. The auditorium that was in horseshoe shape or U shape, and it had a lot of balconies. It was covered. The balconies created a lot of reverberation, a lot of distortions of sound. So to the opera, you'd rather go to see other people and see yourselves in the mirrors more than to listen actually, because the acoustics wasn't so great. Then G was the Wagner Theater. It was the theater that created some sort of boundary between the past and the present of acoustics. It was a theater where you could actually hear the music, hear the actors. It was almost shoebox shaped configuration with a gently fan shaped auditorium and almost rectangular stage. And then we see H. It's a shoebox shaped configuration. It was popular from 19th century. It's popular nowadays. And E is the theater, is the configuration that is called vineyard. It's basically for concert halls. You don't meet the vineyards in theaters. And this configuration with different shapes that you can see here, starting from A, finishing at H, is nowadays can be created into the hybrid design, the one that you could see in the Palace of Culture. So the mixture of configurations to give the perfect sound and give amazing architecture. I will start now from the transformation of the shoebox shape arrangements, the first concert halls. So we can say that the shoebox shape configuration was the first one that was the real concert hall meant for music, not just for theatrical or drama opera performance. Architectural acoustics is a very quite new domain according to the disciplines of science, and the acoustic architecture is considered to be focused on the best performance of sound, depending, of course, on the function of the room. And we have to remember that what is good in school is not good in concert hall, and what is good in concert hall will not be good at the offices. The first rules, first terms and definitions that were formulated according to the acoustics was the definitions from the second half of 19th century. And in the 20th century, the acoustics really grew up basing on the physics. So, of course, the idea of the acoustics of the sound and propagation of sound has started in the ancient Greek. However, the actual scientific basis of acoustics are quite new. Let's go back to the shoebox-shaped holes. So shoebox-shaped holes are the ones that are reminding us a shoebox, and they are designed on a rectangular of the proportion 1 to 2 to 2. So they are quite elongated and quite narrow. Why? Because our ears are on the sides, and the side reflections are very beneficial to our hearing. So the direct sound is reinforced by the sound coming from the side. So the side reflections are especially important while designing the concert halls. This is why the popularity of the shoebox shape configuration is so huge until today. What is also very important, and you can see that on the scheme here, is that the walls shouldn't be perfectly parallel, because if they are perfectly parallel, then in this situation we could occur the flattering echo, which is very, very unbeneficial to the hearing, and it will cause the music to sound terrible. But here you can see that always there are some irregularities on the walls which allow the sound to be directed to the audience without reflecting from one side to the other without end, because it will reflect and it will come back. It's not such a good situation. What is also very important is that on the stage we should have a proper amount of cross reflections. Initially, small shoebox-shaped rooms were popular, recital halls, and George Isenor, one of the scientists connected to the concert hall studies, was sure that it was because of the carrying load span of the structures that were used at the time. So one of the rooms that we say that contemporary shoebox shape started was Leipzig Gewandhaus, and it was Altes Gewandhaus in the beginning for 400 and later on 600 listeners, and then it was so popular that they had to build a new one, Neues Gewandhaus in Leipzig, and it was over 1,500 viewers. As you can see, it was a rectangular room, and then the walls wasn't so parallel at all, because it had these additional arches and sculpturous finishing of the walls. So supposedly there were no flattering echo at that rooms. One of the fully professional rooms, it was the Boston Symphony Hall. It was designed with the help from Wallen Clemens Sabin. He was a physicist who formulated the first formula from the range of acoustics. It was a reverberation time definition. I will be speaking that more on the acoustic classes. And he was helping to build the Boston Symphony Hall. And this room is one of the most most popular because of the acoustics until today. As you can see, it's a shoebox and it has a very flat stage opening, which is very beneficial because the stage from the deeper it is, the more acoustical troubles you can expect. And you can see that the balconies are very flat, so there is no space under the balcony that would distort the general acoustics of the room. And of course, the walls are not parallel, and because of the decoration that you can see here, you can have a lot of additional diffusion, which is actually a very good solution because the sound becomes softer, diffused sound during the reflection. Here are some popular shoebox shape forms. These are the Polish solutions. The large photograph is presenting the Łódź Philharmonic Hall, and you can see that the walls are shaped like some sort of sine wave, which is characteristical for sound. And Opole has different configuration, and it has additional stripe diffusers, which you can see here on the photograph, hopefully. And these elements here are helping us not to have directly the fluttering echo, but also they are serving to diffuse the sound. Also here in Łódź, these elements are actually not only reflecting, but also diffusing the acoustical wave. And one of the contemporary shoebox shape holes, because what I want to show you is that shoebox shape holes are not something of the past. They are being built till nowadays. They are serving their purpose very well. They have very good acoustics. And of course, if you want to have the auditorium over 2,000, 1,800 viewers, then probably you should think about having some more reflective, side reflective walls as you would have in the Vineyard or hybrid configuration. But until this volume, you can think about the shoebox shape configuration and it will work very well. So this is one of the very contemporary shoebox shaped concert halls. You can see it here. It's by Ronda Boavista in Porto, Portugal, and it's Casa da Musica, designed by Rem Koolhaas and Ellen van Loon from the OMA office. The building was prepared for the culture capital in 2001. However, it was finished in 2005. Of course, as you know, during the construction site, we occur many problems and sometimes some of the realizations are being a little bit late. Here you can see the part where the main entrance door are attaching the main entrance. The building is very well connected with the city, and here you can see the statement by the architect that he wanted to do a shoebox shape configuration because it's rooted into the tradition of designing of concert halls. Here you can see the ideas about the openings part of the building in order to open the views for selected views of the city. And you can see here the night view. This is the square in front of the concert hall, and it's very willingly used by young people as some sort of road for bikes and roller skates. This is the main hall, and the view in the main hall is very huge, and it makes a huge impression. The main room is 1,300 seats, so as you can see, the capacity is lower than 2,000 of viewers. It has a lot of additional rehearsal rooms, recording studios, educational spaces, and of course, as every multifunctional building, it has a cafe. And of course, it's a function that goes very well with the concerts and this kind of meetings. The shell structure of the building is actually the construction site of the building, which is very untypical, very unusual solution, and it's very innovative and novel. And the shell is not that thick. It's only 30, 40 centimeters thick, so it's not that a lot. However, the space for the concert hall, the walls of the concert halls are over 1 meter thick. Of course, it's for the construction of ceiling of the concert hall, but also it isolates very well concert hall from any vibrations, any sounds that could go inside. This is a very important solution, and if it's not a wall structure, then it will be full isolation of concrete. This is the layout of the concert hall of the whole building. I will not go so deeply into the details because we are more focused on the hall itself. However, it has a lot of important things. And this is the terrace. It's supposed to be a musician's restaurant. Now it's a restaurant for everybody. It's accessible from the ground floor. And there's a small terrace. As you can see, it goes in line with the square, so it's very public, it's very accessible, very comfortable. Here you can see the parts for the musicians with the dressing rooms, some sort of rehearsal rooms. There's of course an office space and a space for deliveries. You can see the large elevators which allow to deliver things in the large things like pianos in the vertical position, which is always very important for the concert hall. On the first level, we have very representational stairs and a huge ticket room with a shop with a foyer. There are also parts that are not accessible for everybody. They are accessible for the musicians, for the workers, for the staff of the concert hall. Here you can see the main auditorium. You can see the acoustical sluices. Audience goes through the acoustical sluices. The vestibules, so there is no direct connection because it's not only the isolation of the wall, but also it's very important to isolate by the double doors. One thing is that the sound will not go through the double doors. The other thing is that if somebody wants to leave the concert hall during the concert, they go outside, close the first door, and then they open the other. So there is no light going inside the room during the concert, which is very important. Otherwise, it would be highly uncomfortable to see the concert if somebody would have to go out outside of the room. Here you can see the bar and you can see the glass. Both this wall after behind the stage and the wall behind the crown of the auditorium are glazed. Of course, you see the sky through these walls because they are quite high above the ground, but if you go directly to the window, you can see the parts of the city that had to be shown, could be shown from the concert hall. The glass is very reflective if it's a good acoustical material. However, I wouldn't advise you to give it on the back of the concert hall because we don't want any reflections from the back. As I have learned from my colleagues, there is a special curtain which is put to the back of the auditorium, so there would be no reflections from that wall when the concert hall is in use and you don't want reflections from the back wall. As you can see, there's a lot of stairs, but I have asked about it, and people with disabilities can go to every level with these additional elevators that you can see here. So there's a lot of elevators and there is no problem that people with disabilities would not be able to go inside of any area. There are additional rooms, and as I've already mentioned, they are serving the educational purposes. So there are some additional things you can learn while being in this room. Here you can see the walls and also made from glass. So you can, from these rooms, you can look inside of the concert hall. However, you don't see here the concert. So this is the main shop and the main ticket office, the one that I have shown on the layout, and you can see here the stairs that are going all the way through the auditorium, through the public spaces towards the different levels of the auditorium. Here you can see the room, and again the walls are not parallel. You can see a lot of these additional elements that are making the walls unparalleled. Here you can see the acoustical line strap diffusers, and you can see canopy over stage. which is made of acrylic glass, and it reflects sounds towards the auditorium from the stage, which is highly important when the room is as high as this one. And you can see the light coming, natural light coming to inside of the room. This is the bar part, and this is how these glazed elements look like. And they are reminding us again of the graph of the acoustical wave. Canopy over the stage, and this is how the acoustics of the reflections work on these on these elements of walls. And here you can see the data of the acoustical companies who are designing the acoustics and who are tuning the room after it was used. Here you can see the public spaces, the bar, and here you can see also the educational rooms. And now about the vineyard configuration. A vineyard configuration was invented in the second half of 20th century, and it was basically the idea of putting some of the audience in the terrace, but not the balcony. So the terrace, which has a wall underneath, and this wall reflects sound. So it doesn't go under the balcony, it reflects sounds back to the audience, which is under the terrace. Was invited by Lothar Kremer. He was an acoustician working with the concert halls. And first time this concert hall was used was in the room designed by two architects, Rolf Gutbrod and Adolf Abel, and the acoustics was designed by Lothar Kremer. And it was a small recital hall with 800 rooms and 100 seats, and it had two terraces. It was like one full terrace here and one half a terrace. This is how the auditorium looked like. But this side reflection was very beneficial, and also the room was asymmetrical, which is also very beneficial to our ears, because our ears don't like the sound which is symmetrical. When we are inside of the room, the one ear and the other ear are working in order to calculate the differences between when the reflection, the side reflection, comes back to them according to the direct sound. And this is how we orient ourselves in space. So this is how we understand we were placed in the space, not only by our eyesight, but also by our ears. And in this way, this is why we don't like the asymmetrical sound, because when we symmetrical sound, because when we have symmetrical sound, we have no idea where we are. So during listening to the music, remember not to sit in the middle of the audience. So in I think it was 1956, when there was a huge competition for the room for Berlin Philharmoniker, and it was the most famous company in the world from acoustics. It was led by Herbert von Karajan, very famous director. And the competition was finished, and the first project which was selected was designed by Hans Scharoun and Lothar Kremer. Hans Scharoun, of course, famous architect, and Lothar Kremer, the aforementioned acousticians. And what was very interesting is that City didn't want to build this concert hall because it had such a weird shape, and the shape looked like this. So you can see here the layout, and you can see that the room was a little bit asymmetrical. You can see that it had terraces, so it didn't remind it any of the configuration that was known. The stage was placed in the center as a symbol of sound in the middle, as a symbol of reborning of Germany from the war, from these dramatical events. And from the center, from the music, the room was starting to build up, and then it was going through the public spaces outside to the elevations, to the facades, and to the public spaces on the outside. So it was very symbolic, and it was very novel, and they didn't want to build it because, well, let's say this was a very weird configuration. But what was very interesting is that aforementioned Herbert von Karajan wanted to build this concert hall. So he was very set on this, and he said, I will not lead the Berlin Philharmonic if you don't build this hall. Well, so they couldn't afford that, so they just built the hall. And in the beginning, the sound was really terrible. Nobody knew why. But of course, the architects and the acousticians were working on it, and they created this canopy over the stage, which helped to reflect the additional reflections towards the auditorium and cut it off the echo that could be created on the top of the ceiling of that room. And in that way, the concert hall became one of the best acoustics in the world, and it's very famous and it's famous still nowadays. And still, the architects and acousticians from all over the world are coming to see this concert hall and to understand and to learn from it. As you can see, there are pyramidal diffusers here and here. There are side terraces, the walls very close to the listeners. Any place you take, you can see that there is additional space for additional side reflections. So we have direct sound and we have side sound, side reflection to every user of that room, which is very novel, which is very interesting, and is now used also in the hybrid designs. This is how the outside looks like. Of course, it's an architecture that aged, but it is still the configuration of the room is very, very interesting. And I will show you the room which follows basically the rule that you see here. Here you can see the graph designed, drawn by Lothar Kramer. The graph comes from a book by Baron, of course, but the design is by Lothar Kramer, and you can see that it's a study showing that every listener has some side reflection going to them. So the sound in the Vineyard configuration is very blended. It goes from all sides. This is the graph that I've prepared from one of the calls of that configuration. You can see that it's very, very blended. It's not so organized as in shoebox shape configuration, which is quite interesting. Music Italo Concert Hall is placed in Finland, in Helsinki. And this hall is very interesting because it follows a little bit, of course, the Berlin pattern. Of course, it's an individual design and you can see the differences by your own eyes. But it's a very classical type of vineyard configuration. So you can see the side reflections, the audience on terraces. As you can see, the concert hall is very tall, it's very vertical. Here you can see the huge canopy over the stage and the stage itself in the middle between the audience. Of course, the front audience is a little bit larger than the back audience. What is also very interesting, as we saw in Casa da Musica, the concert hall is from 2013, if I can remind you, is the concert hall is glazed. It's glazed on the floor where you enter the main room. So it's glazed from public spaces, and it's glazed 360 degrees. So it's on the glasses everywhere. You can look inside of the concert hall even if there is nothing going on the stage. So it's a beautiful idea, beautiful design. You can see the canopies over the audience as well. And as you can see, they are movable in order to adjust them to acoustics and to different situations. The concert hall was open in 2011, not in 2013 as I've mentioned, sorry for that. And the concert hall has 1,700 people. It has, of course, a lot of additional elements, and it has the academy for students of music faculties. Here we can see that audience is of course asymmetrical, so behind the stage you can see the different volume and different layouts of the terraces as well as on the audience. Look at these stairs. This is what students of architecture are always afraid, that in their concert halls the stairs may have weird shapes, but in the true concert hall where you have to connect all of these levels and rows, this is a normal situation, so you don't have to fear about it. Of course, the stage layout is very classical and it allows you to sit full orchestra, the symphonical orchestra, which is 120 musicians. And what is also very interesting, there's an induction loop which allows people with hearing disabilities to hear the concert better. And it is adjusted for people with disabilities on the wheelchairs. It has 28 wheelchairs seats. Here you can see the exterior of so the box that this vineyard configuration hall is inside. You can see the cloakroom, which is very elegantly designed, and you can see the public spaces, the main communication, and a beautiful artwork chandelier, which is in the main foyer. And here you can see the different settings, different parts, different views for the audience. And as you can see, again, the concert hall is really vertical. It's one of the tallest concert halls that I have been able to be inside. In the contemporary world, we either have concert halls, which are totally designed individually, they don't follow any pattern, we could say, or we have the hybrid design, which connects different configurations with terraces. I could sum it up. Of course, it's a work in progress, so it's very hard to define a typology at once. Here you can see the Butcher Concert Hall, which is designed by Hardy Holzman Pfeiffer Associates, and the acoustics was designed by Chris Jaffe, acoustician, who is unfortunately no longer living. And his idea was not to design a configuration that is shoebox or vineyard. He was designing a halls that he was calling them horizontal or vertical. And Voyager Concert Hall is vertical, and it has very untypical design with a stage in the so-called center with asymmetrical layout of terraces, because these are not balconies, of course. And you can see them here. You would say that this is a very unfriendly design for acoustics because it's focusing, but when you look at these front of the terraces, you can see the pyramids which are going back and forth, and they are diffusing this acoustical wave. And what they are doing, they are diffusing it very softly, very evenly around the room, so the sound is not really focused. Also, you can see here these acrylic glass plates, let's call them canopies, that are suspended, and they are reflecting and diffusing sound back to the auditorium. So this design is very untypical. It also gives a very interesting architecture. And if I could say that there is a typical hybrid design, then probably the typical hybrid design would be Walt Disney Concert Hall, the design by Frank Gehry. The interior of the room is some sort of cross section between the vineyard with archy organic terraces and shoebox shaped configuration. The auditorium in front of the stage, then behind to the stage, is much larger. However, the stage is more or less, it's not in the back of the auditorium, so it's surrounded by the auditorium. You can see the two levels of terraces. You can see that the front auditorium is also placed on the terraces. You can also see additional spaces here in this cross section. This is how the first floor looks like, with again the representational entrance with the stairs. There is foyer, there's lobby, there are places for musicians and artists. There's a choral hall, and this is how the concert hall looks in from the top. So you can see the part behind the stage, in front of the stage. You can see the side terraces. You can also see some additional smaller recital theaters, which you can find here for chamber music, for chamber performances. Here you can see the section and you can see the layout of the concert hall. You can see the canopy over the stage, which also again reflects the sound back to the auditorium audience, which is also very well seen on this graph that was designed, that was prepared, that I found on the website for that room, so you can see how it works in practice. It's a very good graph. I mean, the scheme of the wave propagation is very well designed. So you can see the side part of the terraces, and again, every person you find on the audience, it has the person will probably have some lateral side wall around the ears so they can hear what is going on the stage. And just to remind you, just some simple rules. If we have such a large rooms, you have to remember that you have to have at least two exits. In this kind of concert halls, there are 6 or 8 of them, or sometimes even more, and they have to be a distance from each other of at least 5 meters. What is also very important in the large rooms, that the way of entering the room cannot cross-sect with the evacuation way. So the evacuation has to be preferably directly to the outside, but of course it cannot overcross the way of getting in, because there could be people waiting here and people wanting to evacuate from here, and it would be a huge problem. If someone of you would be more interested in the topic, of course, I know that I've told you also already a lot about the concert halls and the rooms, but if somebody wants to know more, please look at my publications. You can find them at the website of the university, of the database that the university is using. This is my scientist's number, and you can identify by this number my publications. Most of them are open access. Maybe some of them are closed access, but a lot of them are open access, so you can read them. I know that you've already read one of my publications because I asked you to. And if somebody is quite interested in the topic, I highly recommend you Arak Multibook. This is the book that I was one of the members of the huge international team of scientists and writers who were preparing that book. So it's free of charge, it's in PDF file, everybody can access that book. So it's all for you. It's about the acoustics in the architectural world, not only about the concert halls, but there is also a huge paragraph on concert halls. Thank you so much for your attention. I hope you enjoyed this bonus lecture, and let's go back to the classes.